अच्छा bond angles वगैरह. So he's again saying which species is not planar. ठीक है. So the first one that the first that is planar. It's BF3. It only has 3 bonds. ठीक है. How do I know it only has 3 bonds? Because fluorine makes a single bond, so 3 fluorine there, so that's 3 bonds. And boron is group 3. That means it's 1 electron shared here, 1 electron shared here, 1 electron shared here. So piche there's no remaining electrons, right? So that's 120-degree bond angle, and it's it's going to be trigonal planar, this one. As a CH3 plus 1, again it's a carbon with 3 bonds. So it's a carbon with 3 bonds. It's going to be fan-shaped trigonal planar. Achha, does it have any lone pairs? No, it doesn't, because carbon has 4 electrons, right? So 1 electron shared here, 1 electron shared over here, 1 electron shared over here. Plus 1 charge is ka matlab hai the last 4th electron is lost. So there is no 4th electron, which is why it has a positive charge. Okay, so there is no 4th electron, which is why it only has 3 bonds around it. So that is going to be planar as well. C2H4, that will be planar as well. It's carbon with a double bond and 4 hydrogen. So that's a 120-degree angle and 120-degree angle over here as well. So this one is also planar. 3 pairs of bonds around it. So it's 120 degrees. This one is not planar. Okay? Why is it not planar? Because, I mean, that's going to be the answer. Okay, it's got 3 bonds. Like, there's a lone pair on top, sitting on top of it. So it's like a fan that has this kind of wings, and they have been bent downwards. So it's like a pyramid. They're forming a pyramid. How did I know it's got a lone pair? Because it's in group 5. It's got 5 valence electrons. So one shared, one shared, one shared. So do bach ke. So that's your lone pair. So that's why all of the other ones are planar. All of the other ones have an angle of 120 degrees. While this one has an angle of 107 degrees. ठीक है, याद रखना वो angles याद रखना. This one has an angle of 107 degrees, which is considerably shaped. It was tetrahedral basically, right? Trigonal pyramidal, right? It was, I mean, tetrahedral was a 9.5, but if you have a lone pair on top instead of a bond, the lone pair has greater repulsion, which is why the angle kind of shrinks a little bit. ठीक है, तो 107 हो जाता है. अच्छा, अगला वाला, which statement about the ammonia molecule and ammonium ion is correct? इसमें ये वही लास्ट वाला हम कर लेते हैं, बाकी तो I don't think we have done that. Basic because कर लेते हैं. Ammonia molecule is basic because they can a base accepts H plus 1 ions. So the first statement is wrong. It does not donate. Donate is an acid. Ammonium ions are basic because they can accept H plus 1 ions. Ammonium ions are not basic. They're actually acidic. Ammonium ions जो होते हैं ना, they actually lose H plus 1 ions. ठीक है, so they actually lose H plus 1 ions to form ammonia. So that is also not correct. If ammonium ions are heated with NaOH, ammonia molecules are formed. This is correct. It's an equation. It's a reaction where any ammonium salt, when you so C correct है. Okay, any ammonium salt, if you react it with a base like NaOH, what happens is that salt, water, and ammonia are produced. Why is it produced? Because the base accepts H plus 1 ions, and the acid ammonium ions, they act as acids. They lose H plus 1 ions. ये अपने H plus 1 इसको देता है, OH ions को, OH ions become water, and NH4 turns into NH3. So ammonium ions, remember, they are capable of losing H plus one. They're capable of acting as acids. Anyways, वापस deep आते हैं जो हमारा main question था, that the bond angle is 2.5 degree less than the bond angle. So you got three bonds and lone pairs, that's 107. If you have four bonds, the angle is actually 109.5. तो लेस नहीं होता, इसका 107 है. So four bonds का it's a greater angle than it's 2.5 degree difference, but it's greater than the bond angle in NH3. So that's what's wrong with this. अच्छा और क्या है कि how many lone pairs ये कर लेते हैं कि he's saying that this is the structure of C2O. It's C double bond C double bond O. So C double bond O and there's a double bond C. I just need to count the lone pairs. He's saying how many lone pairs of electrons are present in the molecule. So oxygen is group 6. So it's got 6 electrons. 2 electrons are shared over here. So that means there are 4 electrons that are left. As a carbon in the middle is group 4. That means it's got 4 electrons in its outer shell. 2 electrons shared here, 2 electrons shared here, nothing left. This carbon is also group 4. It's 4 electrons in its outer shell. 2 electrons shared over here. That means 2 electrons are left. So इसलिए जो answer होगा ना, that's going to be C. ठीक है, is this one clear?
Yes.
अच्छा अगला, this one, let's skip this. अच्छा let's this could be skip just angles, right? Which pair has species with different shapes, right? So as a B, Cl2 and CO2 have exactly the same shape. It's just 2 pairs of bonds. Remember, B is group 2, so there's no lone pair. Carbon dioxide, same shape, it's linear, and the angle is 180 degrees, so it's exactly the same shape. CH4 and NH4 plus 1 have exactly the same shape as well. Okay. CH4 is tetrahedral. And so is NH4 plus 1. It's NH3 with the lone pairs attracted to an H plus 1. ये हम बाद में करेंगे, लेकिन it's actually 4 bonds. It doesn't have a lone pair. The lone pair gets used up in a bond. It actually reacts with the H plus 1. But we'll discuss dative bonding later. But it's 4 bonds, right? So it's 109.5. They have exactly the same shape. NH3 and BF3 will have different shapes. Okay, NH3 has a lone pair actually, so which is why it will be pyramidal. And your BF3, you know, that's this thing. ठीक है, आपका BF3 है. BF3 only has 3 bonds. This one has 3 bonds plus a lone pair. So this is planar. And this one is pyramidal, trigonal planar, trigonal pyramidal. So C answer, they've got different shapes. SCl2 and H2O will have exactly the same shapes as well. It's 2 Cls and 2 lone pairs. Sulfur is in group 6. Oxygen, the same thing. 2 bonds with hydrogen, and there will be 4 electrons left. So they're exactly, so these ones are exactly the same. So different, जो है ना, that's these two. फिर अगला वाला statement but the ammonium ions are correct. Remember, it's 4 bonds, right? With the lone pair also ending up forming a bond and attracted to H plus 1. The 4 bonds, that's 109.5, not 107. Ammonia ions are formed when ammonia behaves as an acid. That is wrong because ammonia ions are formed when ammonia acts as a base. The ammonia and what happens is that it accepts an H plus 1 ion, so it acts as a not as an acid but as a base. Ammonium ions are unreactive when heated with NaOH. We just did that. Ammonium ions, ammonium salts, they do react with NaOH. So C correct है. तो वापस एंगल्स पे आते हैं कि यूरिया is a product of animal metabolism and can be used as हाँ जी
Sir, ammonium ions are एक second.
ये था ना एक रिएक्शन
सर
होता है
कभी कभार अमोनियम हाइड्रोक्साइड भी तो होता है ना?
क्या
सर मैं कह रहा हूँ कभी कभार अमोनियम हाइड्रोक्साइड भी होता है ना?
हाँ तो तभी वो रिएक्टिव होगा ना अमोनियम हाइड्रोक्साइड तो बेसिकली आपके पास लेट्स से अमोनियम हाइड्रोक्साइड है राइट so that just means that you've got ammonium ions in the solution you've got hydroxide ions and you've got अच्छा अमोनियम हाइड्रोक्साइड अगर होगा ना तो फिर तो NaOH की जरूरत ही है I mean they might react with each other ammonium hydroxide usually ends up forming an equilibrium forming NH3 and water
जी सर.
ये क्लियर है कि अमोनिया को पानी में मिक्स करो ना तो थोड़ा सा अमोनियम हाइड्रोक्साइड बनता है अमोनिया मिक्स विद वाटर राइट
और सर ये अमोनियम क्लोराइड जब हम कहते हैं
हाँ
तो सर तब भी हम इसको अमोनियम आयंस रिफर नहीं करेंगे?
हाँ अमोनियम आइंस ही है ना यानी बेसिकली जो रिएक्शन हो रहा है ना वो ये कि बाकी तो द रेस्ट आर स्पेक्टेटर आइंस राइट whenever an ammonium salt reacts with water तो कोई भी सॉल्ट है तो वी डोंट केयर वो अमोनियम सल्फेट और व्हाटएवर इट इज ठीक है इट्स जस्ट वी आर जस्ट इंटरेस्टेड इन द अमोनियम और बेस व्हाटएवर द बेस इज वी डोंट केयर कि कैल्शियम हाइड्रोक्साइड है क्या है what we are just interested in is we don't care about calcium right we just care about OH the NH4 and the OH they react जो पीछे बच जाता है ना that's the salt calcium chloride but ammonium turns into ammonia it loses an H plus 1 and the OH ends up forming water accepting an H plus 1 clear
जी सर. तो लेकिन हम ऐसे भी कह सकते हैं ना अमोनियम आयंस आर रिएक्टिव व्हेन हीटेड विद NaOH, क्योंकि कभी कभार हम अमोनियम आयंस को अमोनियम क्लोराइड भी तो कह सकते हैं जो रिएक्ट करते हैं बेसिस के
हाँ
साथ.
हाँ हाँ लेकिन उसको भी अमोनियम आयंस ही कहोगे ना कि अमोनियम क्लोराइड भी होगा तो इट हैज अमोनियम आयंस इन इट राइट
जी सर. तो सर फिर उस लिहाज से तो रिएक्टिव हो जाना चाहिए ना व्हेन हीटेड विद NaOH.
हाँ मैं अच्छा नहीं मैंने गलत पढ़ा हुआ है ये अमोनियम आयंस दे आर ऑब्वियसली रिएक्टिव हाँ ठीक है वही मैं बता रहा हूँ कि दे रिएक्टिव राइट तो सी ठीक है
जी सर.
बॉन्ड एंगल्स आर द सेम लेंथ वो खैर अभी आप लोगों को पता ही नहीं है तो बॉन्ड एंगल्स आर द सेम लेंथ दैट्स ट्रू क्योंकि all bonds are with hydrogen so they're exactly kind of the same अच्छा लेकिन वो हम बाद में पढ़ेंगे just the shapes ठीक है just focus on shapes right now what statement of the structure of uric correct what is the angle that's 123 pairs of bonds right so this one is 120 degrees that's fine the molecular तो ये आप लोगों ने नहीं किया हुआ the molecule has only 3 lone pairs of electrons. So does it have 3 lone pairs? Oxygen has 2 lone pairs. Because oxygen is group 6, right? Nitrogen is group 5, so that's 3 bonds, and it's going to have 1 lone pair. This nitrogen will also have 1 lone pair. Carbon in the middle will have no lone pairs because it's making 4 bonds. And it's got 4 electrons, so there's nothing left. So it's got 4 lone pairs, so it doesn't have 3 lone pairs. So this one is also wrong. Is this clear?
जी सर.
Okay, you've got what are the shapes of the molecules? What are BF3s? Remember, planar. It's trigonal, not pyramidal. It's planar. This is BF3. तो बार बार कुछ ही shapes बार बार आ रही हैं ठीक है अच्छा this is BF3 and water was supposed to be but it was derived from a tetrahedral shape but on 2 sides instead of having a bond they were actually lone pairs so it should have had an angle of 109 but it's now just non-linear it's bent and the angle is 104.5 war squeeze हो गया ठीक है this is 120 degrees So the answer is that one of them is non-linear, it's bent or V-shaped, and the other one is trigonal, planar. Not pyramidal, ठीक है? So I said this one, they're asking what are the angles? Three pairs of bonds. I said, remember, this is not the exact shape. So the first one is 120 degrees. The second one around carbon, three pairs of bonds, a double bond, single bond, three pairs. So that's 120, and this one is 109.5. It's got four pairs of bonds. So approximately, which one is the closest? I think C is the closest. अच्छा और बाकी बस उसी तरह ठीक है So और मैं वैसे कोई इंटरेस्टिंग क्वेश्चन देख रहा हूँ कि कोई डिफरेंट क्वेश्चन आ जाए अच्छा वैसे यू गोना गेट प्रीटी मच द सेम क्वेश्चन तो बाद में एंड में ना फिर और क्वेश्चंस कर लेंगे इसके थोड़ा सा वी कैन टॉक अबाउट theory questions related to chemical bonding. तो वो exactly same होगा they're just going to ask you for the shape. अच्छा चलो ज्यादा से ज्यादा शेप के बारे में पूछ लेंगे उसी तरह So the first one, AlCl3, they're just asking for the shape. So AlCl3 will just be three bonds, and the angle will be shape क्या होगी? That's going to be trigonal planar, and angles are 120 degrees. PCl3 that's going to be pyramidal because and the shape is trigonal pyramidal. और इसका जो angle होगा that's going to be 107 degrees. The same shapes. SO3 that's trigonal planar because it's got three double bonds with no lone pairs. Sulfur had 6 electrons, all of them got used up. Or Cl2O, that's O with two Cls. And the O has two lone pairs. So the angle is 104.5 degrees, and this one is non-linear. अच्छा अमोनियम आयन के अंदर वो क्या शेप और एंगल इट्स वो वही है सारे क्वेश्चन उसी तरह ठीक है सो बेसिकली वो भी स्ट्रेट फॉरवर्ड है नथिंग SF6 की शेप क्या है दैट्स ऑक्टाहेड्रल कि एक बॉन्ड टॉप पे एक बॉटम पे एक राइट लेफ्ट फ्रंट पीछे की तरफ ठीक है तो everywhere it's determine the number of lone pairs around a nitrogen atom so that's going to be one over here sulfur पे दो होंगे it's group 6 so it's got 6 electrons 2 shared so 4 electrons left nitrogen has 5 electrons so there'll be 3 electrons left pair of electrons जो होंगे that's going to be 1 because over here he's asking कि lone pairs कितने हैं ठीक है that's अच्छा which one will be तो इसके पास इसके अगर 3 electrons होंगे sulfur around sulfur you'll have 4 electrons so which one would be smaller in size angle wise sulfur will be smaller because it's got more lone pairs so the repulsion will kind of push the bonds together So that one is going to be smaller. ये clear है सल्फर smaller होगा.
सर इतना नहीं
Hmm?
सर, अगर ये ज्यादा इलेक्ट्रॉन्स होंगे तो ज्यादा रिपल्जन होगी, तो लेते हो सर, उसकी वजह से तो ज्यादा नहीं होना चाहिए उसका एंगल।
नहीं तो उसके bonds होंगे वो they'll be closer together, right?
जी सर। ओके,
ठीक है.
समझ।
वो बॉन्ड एंगल्स की बात कर रहे हैं तो वो बॉन्ड्स आपस में ज्यादा करीब हो जाएंगे. Three electrons, they will उनकी repulsion will be slightly lesser, right? So the bonds will be slightly further away. तो वो smaller होगा. अच्छा और क्या है? Which react state the shape SF6 as bond angle of SF6, this is 90 degrees. अच्छा यहाँ पे this one is octahedral. PCl5 shape, तो मतलब काफी straightforward questions है. ये questions इस तरह they're asking कि if you have four bond pairs and no lone pairs, the shape will be tetrahedral, and you have to give an example as well. So the example is CH4. So then you have three bonds and one lone pair. That's going to be pyramidal, because there'll be a lone pair sitting on top of the three bonds. So it's going to be trigonal, pyramidal, and this will be NH3. But if you have two lone pairs and two, that's non-linear. That example is water, ठीक है? तो ये सारे एग्जाम्पल्स हम कर चुके हैं. फिर से वो F6 है तो 6 bonds की क्या शेप होती है? That's octahedral. What is the HCH bond angle at the terminal propene group? तो यहाँ पे what is the bond angle? That's going to be कि अगर मैं H हटाता हूँ ना, that's two H's, right? So that's going to be fan shape. It's going to be 120 degrees approximately, or 119, क्योंकि there are three pairs of bonds. और क्या कोई खास इंटरेस्टिंग क्वेश्चन नहीं है? सेम थिंग जस्ट रिपीटिंग. तो वापस उस पर आ जाते हैं कि अच्छा हम वापस अगला सब टॉपिक स्टार्ट कर लेते हैं. जस्ट वन सेकेंड. अच्छा हम अगला सब टॉपिक स्टार्ट कर लेते हैं, which is we just did shapes of molecules. So we will start with intermolecular forces. ठीक है, and how they're going to affect how the shape is going to play a role in intermolecular forces. So remember molecule shapes. एक से मैं उस जगह पहुंचूं. So now intermolecular forces, they depend a lot on the shape of a molecule. But they depend a lot on other things as well. Intermolecular forces, TK. So that's what are intermolecular forces? When you have a molecule, those molecule you have weak attractive forces. So I've got a CO2 molecule, I've got another CO2 molecule, and I've got another CO2 molecule. Now the reason CO2 is a gas is because they don't attract each other. Or if they attract each other, they don't attract each other very strongly. meaning that if this CO2 is moving over here, no one is stopping it. Okay, so they're all freely, just randomly going about. Okay, so no one is attracting, no one is attracting anyone. Sorry, all of them are moving freely. The weak attractive forces, they are your intermolecular forces. Now, these forces are not always the same. I mean, they're obviously weak. मेरा board hang हो गया. एक second रुक जाओ. अच्छा, जो weak intermolecular forces हैं between molecules every time it's एक second ये वाला hang हुआ होगा. तो ठीक है, लिखा आगे. अब ठीक है. अच्छा, these weak intermolecular forces, uh, they're not exactly the same type. Sometimes they could be strong as well. जैसा water का case है. Water के case में the intermolecular forces are still weak, which means that they're not strongly attracted to each other, but they're still stronger compared to carbon dioxide. तो उनके बीच में ना there's still there's still some attractive forces, which is why water uh, is a liquid. ठीक है. तो इस केस में there's slightly stronger intermolecular forces compared to carbon dioxide. And water solidifies very quickly as well. That means the force of attraction is not that weak. So slightly stronger intermolecular forces. अब इसमें ये कि the intermolecular forces can be divided into three categories. You've got three different types of intermolecular forces. Let's start with the first one. The first one is a permanent. It's known as permanent dipole interaction. Okay, that's the first one. Okay, that's the first one. The second one is known as hydrogen bonding. It's not actually a bond; it's just an attractive force. It's a very strong attractive force. So they're known as hydrogen bonds. So there's certain molecules that are capable of forming hydrogen bonds. The third attractive or intermolecular force is known as van der Waals forces, and it's known by many names. It's also known as temporary dipole induced dipole. But temporary का word अब use नहीं हो रहा. They use instantaneous dipole. As an instantaneous dipole induced instantaneous dipole induced dipole. And other names as well. They're known as dispersion forces. The third वाले के ना ये सारे नाम है. Now, relatively speaking, remember all three of them can be very strong and they can be sometimes weak as well. But इसमें बीच में जो हाइड्रोजन बॉन्ड्स है ना, relatively speaking, they are usually the strongest. Anything that has hydrogen bonds, that will probably have a very high melting and boiling points. As lots of properties depend on intermolecular forces. Like what kind of properties depend on वो main में कर लेंगे, like melting points, boiling points, a lot of physical properties, even reactivity. If molecules don't attract each other, they won't react with each other. So even reactivity, chemical reactivity also depends on how the molecules attract each other. So one by one, now we're going to study intermolecular forces. Now, most of these intermolecular forces, the three types of intermolecular forces, they depend on a difference in electronegativity, which is that when we did the periodic table, the first thing that we did was I told you okay, the most electronegative elements are going to be on the they are going to be on the right side. The most electronegative elements. They're going to be on the right side in the top right corner. Okay, so that's the most electronegative side. These atoms really like to gain electrons, and the ones on the other side, they're going to lose electrons, right? Like for the compound to be ionic, you had to have a difference in electronegativity of greater than 1.7. वरना वो एक dipole बनेगा. For example, if I have HCl, ठीक है, so if I have an HCl molecule, now HCl is a covalent molecule. How do I know it's a covalent molecule that the electrons are being shared? That although there is a difference in electronegativity, but it's not very high. Okay, remember 1.7 से ज्यादा electronegativity difference होगा ना electro Falling scale. Just 1 second.
सर इससे पहले डेटिक बॉन्डिंग नहीं करनी?
नहीं, वो माइंड में बॉन्डिंग वगैरह माइंड में करते हैं कि वो टाइप्स ऑफ बॉन्ड्स जो है ना वो माइंड में पढ़ते हैं. ठीक है,
ओके सर.
उसमें सिग्मा पाई बॉन्ड्स वो सारी चीजें आ जाएंगी उसमें. sp3 हाइब्रिडाइजेशन, sp2 sp, वो सब एंड में करते हैं. आसान वाली चीजें वो पहले कवर कर लें कि इंटरमॉलिक्यूलर फोर्सेस का बॉन्डिंग से तो कोई ताल्लुक नहीं है, जो मर्जी है. अच्छा, फॉलिंग स्केल. अच्छा, ये वैल्यूज लिखी हुई है तो यहाँ से ना जस्ट पिक द वैल्यू कि H और CL. H is 2.3 and CL is what? Let's call it 2.7, right? So 2.3 and 2.7. So that is clearly, I mean, they've remember for covalent bonding, the electronegativity values must be very similar. Only then will the electrons be shared, because no one is pulling the electrons very strongly to one side. Actually, like in which one is more electronegative in this case? It's Cl that's more electronegative, right?
जी.
So that means कि जो electrons है ना, these electrons will be slightly closer to Cl. थोड़ा बहुत Cl के करीब होंगे. I mean, Cl will not gain those electrons because it doesn't have a very strong tendency to gain electrons. Plus, electronegativity difference भी इतना ज़्यादा नहीं है, so the electrons will be closer to Cl, but it won't be gaining those electrons. But if the electrons are closer to Cl, there's going to be a dipole that's going to be produced. The hydrogen will be very slightly positive, and the Cl will be very slightly negative. ठीक है? So that's known as a permanent dipole. इसको मैं heading एक second दे दूं permanent dipole की. So that's known as permanent dipole. That's the first type of intermolecular force that exists. Uh, so when there's a difference in electronegativity, so whenever there's a difference in electronegativity, It also depends on the shape. अभी shape हमने discuss नहीं की, but whenever there's a difference in electronegativity in a bond between atoms in a bond, the electrons will be unequally shared. And this resulting in slight negative and slight delta negative actually, and slight positive. So minor positive, minor negative charges on the atoms. The electrons will be towards one of the atom. तो इसमें ये लिख लेना कि shape, it depends on the shape as well. The dipoles don't cancel. वो हम अगली क्लास में पढ़ेंगे. लेकिन that's what a permanent dipole. It's a permanent dipole. Permanent का मतलब it's always Cl will always be slight negative and hydrogen will always be slight positive. The one that's more electronegative is going to pull the electrons closer to itself. Ionic में क्या होता था? There was a huge difference in electronegativity, so the electrons will be pulled completely towards one side, resulting in a -1 charge on one ion and a positive charge on the other one. यहाँ पे बस थोड़ा सा हो रहा है, slight negative, slight positive. Is this clear? सारों clear है?
सर हाइड्रोजन और क्लोरीन के दरमियान तो कोवेलेंट बॉन्डिंग होती है.
Covalent है ना? मैंने
तो
तो
सर लेकिन ये तो इंटरमोलिकुलर फोर्सेस की टाइप्स है ना. तो इंटरमोलिकुलर फोर्सेस कोवेलेंट बॉन्ड्स के दरमियान बनती है ना.
हाँ
यानी
तो
एक कोवेलेंट बॉन्ड और दूसरे कोवेलेंट बॉन्ड के दरमियान.
हाँ तो ये कोवलेंट है ना. तो इसकी वजह से वो आगे हमने अभी बात की नहीं है, लेकिन इसकी वजह से what will happen is that if there's two HCl molecules, right? So there's one HCl molecule and let's say there's another one. Will they attract each other? उसका जो positive hydrogen है ना, that's going to attract the negative Cl of the other molecule. That's known as a permanent dipole interaction. Permanent dipole of one molecule attracts the permanent dipole of the other molecule. अगर ये neutral होता ना, ये भी completely neutral होता, तो there will be no attraction. Clear है ये?
जी सर.
So dipole clear के dipole gets created on a molecule, and obviously the other molecule will also have that dipole. So the positive end of one molecule will attract the negative end of the other molecule. So that's the first one. That's a permanent dipole. अच्छा तो ये आपकी permanent dipole interaction है, ठीक है. और इसको खैर डिटेल में नेक्स्ट क्लास में डिस्कस करते हैं, सही है. कोई क्वेश्चन नहीं है इसका?
नो सर.
तो चलो ठीक है, फिर कल बात करते हैं इस पर. कल होगी क्लास, ठीक है.
सर ये परमानेंट डायपोल इसलिए क्योंकि वैन डेर वाल्स में वो डायपोल्स बदलते रहते हैं.
हाँ ये परमानेंट है, ठीक है. वैंडरवाल्स इसमें,
चेंज.
वैंडरवाल्स एक्चुअली इसमें भी होगी, लेकिन वैंडरवाल्स पे आते हैं बाद में, ठीक है.
ओके सर.
चले, ओके, ठीक है.
अल्लाह हाफिज.
हाफिज.